Welcome to my talk, Finding Peaceful Coexistence Between Apache Cassandra and Kubernetes. It's quite the title in this one. My name is Chris Bradford. I'm a product manager at DataStax. I work on the Cassandra open source project along with the Cas operator. And we're really going to explore two distributed systems here. We're going to talk about Kubernetes, we're going to talk about Apache Cassandra, and what makes them an interesting match here. So let's get into it. So first up, I know we're here at KubeCon. What is Kubernetes? This is a question that really needs to be asked. Well, let's just cover it at a high level. So first and foremost, Kubernetes is a distributed automated container deployment platform. And what does that mean? So it's a way to deploy containerized apps on hardware, both physical and virtual. It handles taking a container that's basically an app that's wrapped up with all of its dependencies so it can run. And then, well, it runs it somewhere. As part of that platform, I like to think of Kubernetes as an API platform. Specifically, there's tooling, whether that be clients as well as controllers to interact with its control plane, and it's the way that we run these containers. It provides tooling to kind of expose this functionality, check on status, watch for events, that kind of thing. And then one of my favorite quotes is that it's the operating system of the data center. So we stop thinking of the operating system that runs on the individual machines in the data center and think of it as a larger scale computer. I'd like to think of Kubernetes as the operating system for that computer. And it's going on 7 years old this year. It came out in June of 2014. And then the other side of this talk is Apache Cassandra. So what is Apache Cassandra? Well, it's a distributed NoSQL database. It's used for massive scale at places like Netflix, Apple, and Sony Computer Entertainment. It's peer-to-peer, so there's no leader, follower, or primary, secondary, or read replicas, that sort of thing. Any node in the cluster can answer any query, and it will forward it to the queried nodes where the data lives, that kind of thing. But I like to say that it's availability first. If you are familiar with the CAP theorem, where it's consistency, availability, or partition tolerance, Cassandra is firmly in the availability and partition tolerance space, which is pretty great. And then finally, when we say distributed, what does that mean? In the case of Cassandra, it means that it's multi-region and multi-availability zone aware. This aligns nicely with the terms inside of the Cassandra space is the logical data center and the logical rack, which names are derived from the physical data center and the physical rack. And the nice thing about these failure domains that it's aware of is you can reason about how it will behave when an entire rack goes down. It still has multiple replicas available and can respond to queries. What happens when an entire data center or region goes down? Well, it still has multiple replicas and it can still answer queries. And then there are tools within it, within Cassandra, to deal with reconciling the drift of data between different replicas, whether that's repair or we call it repair, it's an anti-entropy mechanism, or during the read path, it can say, hey, this piece of data didn't look right. Go ahead and update the data that you have there on disk. So why hasn't Cassandra on Kubernetes happened already? Well, it has, and I've talked to users that are have been doing this for years at this point, right? But it really hasn't been super simple, and that's due to a number of reasons. You'll see the term maturity is used here. I'd love to dig into what we mean by maturity. So, it's not to say that these things were just like pet projects that weren't ready for prime time. That is not true at all. Kubernetes has been doing great for years now. I just want to, when I say maturity here, I'm saying how we can get from the innovators and the early adopters into mainstream usage. And by increasing the maturity by these components growing over time, it becomes much easier to have these conversations around running things like databases on Kubernetes. So what do I mean by API maturity here? In this case, I want to know if the primitives or the resources exist within Kubernetes that I can safely leverage. So where in my first generation of Kubernetes, I might just be running a bunch of pods and managing things like setting up my storage and configuration on a per pod basis. Nowadays, I can use something like a stateful set, which has handles the storage for you natively. It keeps a persistent identifier for the lifetime of that pod, or for the lifetime of the stateful set. And so the resource primitives, the Kubernetes resource primitives, support what I'm trying to do. And then there's runtime maturities. When I say runtime here, I'm talking about the container runtime. Historically speaking, there have been issues with storage within the container space, whether that be a piece of storage that you've mounted into the container, or you're just using the native container storage that's there for the life cycle of that container. And there were performance concerns. And so you didn't want to put your database inside of a container because there's a cost doing that. And then finally, there's ecosystem maturity. So this is everything surrounding the API and the runtime. So we think about storage, networking, operators, and other tools like Helm, that kind of thing, that previously just had kubectl. And now we have a more richer ecosystem that allow for some more advanced usage. But to go back to that original question, though, some users have, they've been running Cassandra and Kubernetes for years. It's not to say it was easy. They've invested a lot of time and resources into building up this knowledge and this know-how. And I've seen some of them even go from these pod-based deployments where you're managing each individual piece to embracing the operators, embracing the Helm charts, embracing the new functionality as it becomes available. So why do we want to bring a database to Kubernetes? Well, first, Kubernetes, like we said before, is an API platform. And I'm not talking about the APIs like what you would write for like a web application. Now, you could certainly make the Kubernetes API do that. Not that I recommend it, but it's possible. But the key point here is it's an extendable API. And when we say extendable, it means you can bring your own domain, your own logic to this space. So in the realm of running Cassandra on Kubernetes, I might talk about a Cassandra data center to Kubernetes. Kubernetes has no idea what a Cassandra data center is, and that's okay. But I can, through the use of tooling like operators, I can extend that API and say, hey, Kubernetes, here's a Cassandra data center. And then Kubernetes can say, I don't know what to do with this directly, but I know who to talk to. I'm going to pass this Cassandra data center over to them, and maybe they'll do something interesting with it. And in our case, we do the translation from that logical Cassandra data center into stateful sets and persistent volume claims and services and all that stuff. It also allows for the automation of traditionally time-consuming and tedious tasks. So one of my previous roles was to work in the network operations center for a streaming video game company. And I was from 10 p.m. to 7 a.m., I was deploying new software to servers and remediating issues. And when I look at what we were doing there, where we had pretty advanced run books of what to do when X or Y happens, especially around the databases. So in that case, we're running a relational database with a primary and many read replicas. And one of the common things that would happen, maybe too common, but one of the common things that would happen would be when a primary goes down, you'd have to promote a secondary up to become the new primary. And it was somebody's job to go through and reconcile what hadn't necessarily made its way to that replica, which was not an enviable task at all. And so one of the things that's fascinating here about the Kubernetes API and interface is we can then say, okay, hey, Kubernetes, when something happens, I want you to let me know, and I'll run some code to fix it or do something with that information. Maybe it's just logging, maybe it's rescheduling the pod or what have you. But really, we want to bring databases to Kubernetes, because it can make our operational life simpler. We're speaking a common language amongst software vendors and cloud providers around deploying applications and containers and stateful and stateless workloads. That's the common part of the common extendable API, is that it's a language of the data center and the language of deployments of ops these days. So it gives us a lot of power from an operations perspective. So what's changed? Why are we saying, you should run data on Kubernetes now? It's not entirely unreasonable. Here, I'm talking about persistent volumes, stateful sets, CSI, CNI, and you might be looking at these and going, hey, Chris, this isn't new. What do we mean? What has changed? And just like that slide a few slides back where we were talking about maturity, it's about how these have grown over time. So in the case of persistent volumes, we see new features such as snapshots and expansion of those volumes being supported by the CSIs underneath them. With stateful sets, when those came into being, you now had a persistent identity and storage to go along with your pods. The pod goes down, it comes back up. It still has its storage, which is pretty fantastic. With the CSI changes, you look at solutions by MyData and Recto, where you have native backup support at the storage layer, and you can take these snapshots where previously we had to have custom tooling to say take some files off disk and toss it out to an object store. And then finally, with the CNI, when we talk about Cassandra, we talk about multi-region. In the scope of Kubernetes, that means multiple Kubernetes clusters. And so you really have to think about the shape of your network deployment. What do my IP addresses collide across these two different clusters? How do I deal with getting from one VPC to another? Am I using private links? Am I using IPsec? What does that look like? Is that handled natively for me inside of my network interface, or do I have to bring that to the table? Some of the things that you see that are kind of fascinating here are multi-cluster routing, eBPF. I'm a big fan of what Cilium's doing, and sidecars like Envoy, where you can define these really interesting network topologies across cluster boundaries. And that's a really big deal when we talk about a multi-region database where your total existence is outside of the bounds of a single cluster. So how have we, so with all these things changing, right? And the fact that we want to run databases on Kubernetes, how have we done this with Cassandra? So in the case of Cassandra, we've created Cassandra, which is the merging of the names Kubernetes and Cassandra. So we like to call it a complete Apache Cassandra-based data platform. This is backed by a number of operators, and it's not just deploying Apache Cassandra on Kubernetes. That's been done, and with in a number of different approaches. But what this is it's Apache Cassandra. It's Stargate for your API services. It is backup and restore, is observability and monitoring, all under one big umbrella. You say, give me a Cassandra cluster, it comes back and it's ready for production. And that's a big deal. If I were to go to many operation shops and say, okay, I've got your production Cassandra cluster ready, you're good to go, and didn't have these other supporting services, I get some funny looks. And for what it's worth, that's happened before. So let's look at the history of Cassandra, though. It was born out of Astra, which is DataStax's Cassandra as a service or database as a service offering. So when we were building out Astra, we said, we want to run this on Kubernetes. That makes sense for us operationally. How can we make this easier for us to run Cassandra on Kubernetes? So we built out the CAS operator. CAS operator does one thing. It takes Cassandra data centers and it turns them into pods that are resources that Kubernetes understands, in this case, stateful sets, and services, and that kind of thing, which is great. But like we said, we need to have a really cohesive experience. We said, you know what, let's expand this to form an opinionated way to run the entire stack on Kubernetes. So we have things like Medusa, which is an Apache Cassandra complementary technology that handles the backup restore. We have Reaper, which does anti-entropy repair in an out-of-band fashion. We've got monitoring with Prometheus Grafana. And this whole experience is, like we said, how we want to run production. Now, you might be saying, I already have my own Prometheus Grafana, Chris. I don't need yours. Or maybe I have this other solution and I really don't want to use that one. Am I stuck using those particular components? No. Cloud native, part of being cloud native is to be composable and to build systems that are made of multiple solutions that fit. And so one of the things that I really like to focus on when we talk about Cassandra and Cassandra and Kubernetes is that we have the hooks in place for you to bring your own monitoring system into place. Bring your own API layer, however you want to go about this. You can disable certain pieces, and as we and substitute it in your own. And as we grow as a community and as a project, we're hoping to have tighter integration with other projects that make sense. Like Cert Manager for TLS, that'd be a great addition to loop in. So that doesn't mean everything's perfect right? We've been CAS operator came out over a year ago now. Back in November QCon, we announced Cassandra, and in February we had the 1.0 release of Cassandra. So it's been really rapid, and we've learned a lot as well. So let's talk about some of these growing pains with running Cassandra on Kubernetes. This isn't just Cassandra related. This is just when you have two distributed systems that maybe do things slightly different, or have different experiences, you got to reconcile those some ways. And so these are some of the things that we've run into. So one thing that we've seen is ephemeral identity. So while stateful sets give you a persistent identity, it's at the host name level. Your network identity can change. If a pod A goes down and gets rescheduled on worker B and comes back up, it has the same host name, but it has a different IP address. And in many cases, this is okay. But in the case of Cassandra, that IP address has a little bit of state associated with it. And if two pods were to swap IP addresses, that could put us in a bad state. So there's work going on to make Cassandra a better citizen in the cloud native space. Storage. In some cases, the storage can move. In other cases, the storage can't move. And what do you do in that case? In the case of CAS operator, it'll say, oh, the storage can move. I'm just going to, the pod will get rescheduled. It'll come right back up. But if that's not possible, it has to then decide, okay, do I replace this pod with a new pod that's empty and let it build its data back up off the other replicas? And there's reasons you would or would not want to do that. And so there's some of these, you can kind of see the where, okay, I could see how this has changed over time. And we're working actively with the upstream projects and within the project itself to make this a lot more friendly experience. Another example is a misbehaving Unix tool. So one of our containers in one of our pods just tails out a log file. No big deal, right? But we noticed that when we went to terminate a Cassandra data center, it would take minutes to tear down. We're like, this makes no sense. It should just be dropping in the process and getting rid of the data and away it goes. It actually turns out that the tail command does not respect sigterm, which Kubernetes was sending it to clean up and to go down. And so it would wait until it timed out, and then Kubernetes would send the sigkill command to that process. And so we've had to change like how we launch the tail command to get access to certain log files. Just kind of fascinating kind of bumps in the road that you experience. And one of the last things here that I think is kind of fascinating is DNS caching. So in Java, which Cassandra is written in Java, an IP address can be resolved, or sorry, a DNS name will be resolved to an IP address. It doesn't always happen multiple times though. So if when I first start the cluster, one of the pods has, or maybe the service name has like these 3 IPs, and over time pods get replaced and what have you. If this process hasn't restarted, I don't know anything about those new IP addresses. And so we've, again, just changing some settings in the JVM to say, hey, you should refresh your DNS every once in a while. It's not going to stay the same. And just interesting kind of behaviors. But that leads to the question is, what's next? So we have Cassandra, it's running Apache Cassandra on Kubernetes. We think it's a great data platform. What's next for the project? Well, it's not done. There's certainly always new interesting things happening in the cloud native landscape, but also things that we can do better. So we look at, so for example, here we have effortless security and observability. We really want to embrace TLS and MTLS. Sure, we can configure it ourselves, and we do in some cases, but like hooking into things like Cert Manager to generate our certificates for on a per pod basis and wire it all together. We're turning around saying, you know, I really like what's happening with service meshes, right? I did a great POC with Linkerd, and the MTLS on that was effortless. I didn't have to do anything. It was awesome. And should we work on making our MTLS story better with outside of a service mesh, or should we just go all in on the service mesh? These are some of the things that we're exploring. Another item was multi-cluster topologies networking. One of my favorite talks out there is, why is Kubernetes networking so dang hard? And one of the things that is kind of fascinating is you could have a flat network where a pod in cluster A can talk to a pod in cluster B. You could have totally isolated networks. You could have IPsec tunnels running between your clusters. You could have we talked about Envoy a little bit earlier, where you would take and have like a separate IP space for all your pods that's separate from the pod IP space that's generated by Kubernetes that could be persistent. Uh, so exploring what the shape of these multi-cluster topologies look like and how the pods ultimately talk to each other, because that's like the most important thing in a multi-replica setup. And then finally, embracing modern cloud native solutions in a project twice as old as Kubernetes. So one of the things that's kind of fascinating is if I look at uh, the control plane for Kubernetes, look at etcd, look at all the pieces there. There's some things that like Cassandra has had to do because they didn't exist at the time, and that maybe there are solutions that are native to Kubernetes into the cloud native landscape that make a little bit more sense. And so that's one of the things that we're doing is embracing modern cloud native solutions. So DataStax's Astra Serverless is a great example of this, where we've done work with Cassandra to make it use some of these systems internally and provide a better experience. And we're working with the upstream project to make those available to everyone. And finally, just as a call to action, some questions here, but call to action, check out the DataStax workshop tomorrow, running a cloud native data tier with Cassandra on Kubernetes. It's a whole walkthrough of how to install through checking out the monitoring, running repairs, taking backups, everything. And then finally, we just launched an updated community site at cassandra.io. We'd love to have you join us there, talk about how you run your data on Kubernetes and what we can do as a project to enable you further. So with that, thank you so much for your time.